Imagine a realm so massive it literally makes up the largest living space on Earth, yet it's still shrouded in almost total mystery. Welcome to our latest explainer. Today, we're descending into Earth's final frontier, the deep sea. We're going on a cinematic journey down into a world of absolute, inky darkness, freezing temps, and just unimaginably crushing pressures. We'll be looking at totally alien-like creatures, mind-blowing technological feats, and, well, some pretty hidden threats too.
Okay, let's dive into this. It's honestly one of the most profound paradoxes of our time. Think about it. We can map the surface of Mars with staggering precision, right? We literally point telescopes to the very edges of the observable universe. But when we look back down at the blue marble we actually live on, we have a massive, glaring blind spot. When you picture the sheer volume of water covering our globe, how much of it do you think is actually known to us?
The answer is honestly shocking. Even though water covers over 70% of Earth's surface, more than 80% of that marine realm is completely unknown and unmapped. Just let that sink in for a second. 8 out of every 10 square miles of the ocean floor and the huge column of water above it is entirely alien to us. It's a massive, unexplored frontier right here on our own planet, hiding ecosystems, geological wonders, and biological secrets that we are absolutely only just beginning to uncover.
Section 1. Surviving the Deep Dark. Let's talk about these hostile environments.
So as we drop past those sunlit top layers, the environment gets hostile fast. We're talking inky darkness, near freezing temperatures, and pressures so intense they'd crumple a modern submarine like a tin can. But life doesn't just survive down there. It adapts in the most magnificent ways. Take one of the ultimate masters of the deep, the sperm whale. Just recently, during an expedition on the Ocean Explorer vessel, scientists managed to stick a camera tag on one to film a deep dive, something nobody had ever captured before. And what they saw was wild. At about 275 meters down, the whale's tail, its fluke, stops moving almost entirely to save on precious oxygen and energy. It basically freezes its fluke and just lets gravity drag it down into the abyss, plummeting to 455 meters in total stillness before it finally starts echolocating to hunt. I mean, what a brilliant survival tactic in such an unforgiving place.
Section 2. Tools to map the abyss. We are definitely in the golden age of tech for this.
Now, you might be wondering, how on earth do we explore a place that's fundamentally lethal to humans? Well, we rely on some pretty magical tools, but surprisingly, the journey actually starts way above the water. NASA's PACE mission, that's Plankton, Aerosol, Cloud, Ocean Ecosystem, gives us a revolutionary view right from low Earth orbit. Using its ocean color instrument, this satellite actually observes over 100 different wavelengths of light bouncing off the ocean. That lets scientists analyze microscopic phytoplankton communities all over the globe, every single day. So before we even dip a robotic toe in the water, we're tracking the foundational organisms that produce literally half of the world's oxygen and drive the whole food web.
And this brilliantly illustrates what happens when we do move beneath the surface, because the tech totally shifts. For decades, scientists just blindly dragged physical trawl nets, which, only gave us a tiny, fragmented picture of what was down there. Now, we use AUVs, autonomous underwater vehicles. These unmanned drones navigate completely on their own, diving straight into places like the Kermadec Trench. They use high-resolution multi-beam sonar to bounce sound waves off the seafloor, creating these incredibly intricate 3D bathymetric maps. They can locate everything from hidden underwater volcanoes to chemical-rich hydrothermal vents where entirely unique life thrives.
But what about the life forms that sonar can't see? Enter environmental DNA, or eDNA. This is an absolute game changer. Just like we shed skin cells, marine animals shed DNA into the water as they swim around. Scientists can literally just scoop up a water sample, sequence the genetic footprint inside it, and know exactly what elusive species were just swimming through that exact spot. It's completely non-invasive and highly accurate. It lets us track shifting marine ecosystems, like out in Monterey Bay, without ever needing to capture or even see the animals.
Section 3. Life in the Shadows. Let's look at some mind-bending new discoveries.
Armed with these advanced tools, we're finally bringing the deep sea out of the dark, and we're discovering species that totally challenge our understanding of biology. In a world with zero sunlight, marine life just invented its own. Bioluminescence is this chemical cold light produced right inside an animal's body. By mixing a molecule called luciferin with oxygen, they glow. And since blue and green light travels the furthest in seawater, the deep ocean is essentially a neon light show. These creatures use it in crazy ways too. Deep-sea anglerfish dangle a glowing lure to snag a meal.
The vampire squid shoots out glowing, sticky mucus to totally confuse predators, and some shrimp use a dim glow in their bellies to match the faint light from above, basically becoming invisible.
Now, what's really interesting about this slide is how it separates what we absolutely know from what we're still figuring out. On the left, we've got a confirmed hard fact. The Hawaiian bobtail squid takes in bioluminescent bacteria right after birth. It feeds them, and in exchange, the bacteria provide light. It's a proven, beautiful symbiotic relationship. But on the right, we have what's called a working scientific hypothesis, the burglar alarm theory. Researchers think that some creatures might flash super brightly when they're attacked to actually attract an even bigger predator. The hope is that this newcomer will eat the original attacker, giving the prey a chance to escape. It's a genius idea, but scientists are still actively studying just how often that actually works out in the wild.
As captivating as all these discoveries are, there's a darker reality we really need to address. You'd think that living thousands of meters underwater would protect these ecosystems from human impact, right? Sadly, no. Heavy metals like mercury, cadmium, and lead, along with manufactured chemicals from our everyday products, are actively making their way down into the abyss. They're infiltrating the deep and threatening these incredibly fragile, slow-growing ecosystems before we've even had a chance to fully understand them.
And honestly, the most terrifying part? We are kind of flying blind here. When the UNESCO Intergovernmental Oceanographic Commission recently tried to put together a summary of global ocean pollutants, they found they literally couldn't even fill a single page. The data gaps are just massive. We have a scale gap, meaning we can't apply local findings to the wider oceans. We have a geography gap because we know almost nothing about the deep and open waters compared to our coastlines. Plus, there's a huge lack of long-term monitoring. Out of the 350,000 manufactured chemicals currently in circulation, the vast majority are completely unstudied when it comes to marine environments.
Section 4. The race to 2030. Let's talk about the mission to map the ocean.
Thankfully, humanity isn't just sitting around in the dark. To protect the ocean, we have to understand it. And to do that, we absolutely have to map it. Enter the Seabed 2030 initiative. Launched by the Nippon Foundation and JEBCO, it has one monumental goal: to deliver a complete, high-resolution map of the entire ocean floor by the end of this decade. It's a flagship program of the UN Ocean Decade, and it is moving fast. By teaming up with global partners, crowdsourcing data from commercial ships, and launching fleets of autonomous vessels that map the seabed for months on end, we're rapidly filling in the blanks. It is just a stellar example of global teamwork and cutting-edge tech coming together for the planet.
Section 5. Mysteries yet to surface. We are just scratching the surface.
So, the crucial point is this. Every single time we lower our camera, launch an AUV, or test a drop of seawater, we're pulling back the curtain on a world that's been isolated for millions of years. But we are quite literally just scratching the surface. Eric Stackpole, an ocean tech innovator who actually helped get that amazing sperm whale footage, summed it up perfectly. He said, exploring the deep, you often see something that you've never seen before. But you hope that you're going to see something no one has seen before. And honestly, that hits the nail on the head. That's the heart of deep-sea exploration, that unyielding drive to push into the unknown and witness the impossible.
As we race to map that remaining 80% of our ocean, as we decode the glowing languages of alien creatures, and as we fight to protect these waters from unseen threats, we are just left with this incredible sense of awe. Think about it. If we've already found glowing sharks, bone-melting worms, and whales that freeze their tails to plummet into the abyss, I leave you with this to ponder. What else is lurking down there in the unmapped dark, just waiting to be discovered? Thanks for exploring this vast unknown with us today in this explainer.